recording now. I think it says recording. There we are. I'm going to share my screen. Desktop number 2, share. All right. Can you guys see Rhino open on a monitor here? Hopefully. All right. So, anybody wants to chime in or shout the answers? Feel free. But I need to go open up Grasshopper. I have Rhino open. I need to go open up Grasshopper. What do I do? Some of you know this, if not all of you.
You can type Grasshopper into the command bar.
Say that again.
Type Grasshopper into the command bar.
Right, yeah, it's just a command in Rhino here. So if I type in Grasshopper, right, and it says, oh, okay, just hit enter in the command line. And it brings up Grasshopper. There's also a little icon, actually, right up here. It's a little green circle with the Grasshopper head and antenna on it. All right, so that brings up a new window called Grasshopper. It sits over top of Rhino, okay? So I'm gonna go ahead and open up some of these files just to show you. So it's called Soloit Graphs, with, I think with modifications or something like that. It's a zip, again, that's a zip file that you can download. You don't know what a zip file is, it means you can take a folder of stuff and then zip it into one file, like an archive. Then when you download it onto your machine, you can unzip it and unarchive it, and then it's a folder on your machine again, okay? So you can always right-click on the zip file. If you're not using a Mac and it doesn't unzip it for you already, you can just say unarchive or open or unzip. And let me just open one of these up. Let's see, ARCS plus 118. Oh, wow, this is pretty interesting. Let me just back up for a second and open up a different one, and I'll show you. Let's open up 118. I'm sure, so I saw a number of you actually do this one, right? This was a certain number of points evenly distributed across the wall, and then every point connects up to every other point with a line, right? Something like that. Probably much more eloquently and concisely stated than what I just did, but shall we take a look? All right, so there's not a whole lot here. What I've done is let's just take a look, because you know, part of what we're going to be doing this class is sort of looking at a task that we need to perform, or what do we have as ingredients and what do we want at the end. And then we have to sort of develop the logic, the pseudocode, the algorithm in order to sort of take the ingredients and then do stuff with them in order to build whatever we need with them, okay? So oftentimes that word that I just used, pseudocode, is really the sort of modus operandi here for how we work. Whereas we're gonna try to figure out, just like if you were sitting at your drafting table, you know, in second year with your triangles and your T-square, trying to figure out how you go from a blank piece of paper to this elaborate drawing. You know, you would have to think step by step on how to do this digitally as well, okay? But again, remember, we're actually planning out the process here and then plugging some things in, and then Rhino is actually modeling and drawing everything for us in real time, okay? So let's take a look at this recipe. The first thing we need to do, right, is to create a bunch of points evenly distributed across the wall, right? And so this first widget is called populated two-dimensional region with points. It sort of defines a couple of random number seeds, right? Then it plugs in a bunch of random numbers for X, Y, and Z coordinates. And then actually just X and Y. Z will always be 0 since it's a two-dimensional field, two-dimensional region. So it populates this with points, and then all we have to do is tell it how many points we want, and whatever seed, random seed or random seed for the engine we want. And then it pops out a bunch of points, right? So there you'll see a bunch of green X's. Those are the points that are generated. Then what we do is we tell Grasshopper to take every point in this list and match it up with every other point in this list. And then we just draw a line. But instead of just adding one start point, one end point, we give it a list of start points and a list of end points, and it does it all for us in one widget, okay? I know, it seems weird, eh? But the nice thing is now we can continue to add the number of points for some sort of desired density. And we can also change the configuration of points so we get something that looks the best or is the most evenly distributed across that sort of that box that we have on the wall, right? All right. So for 118, you guys did that. Now I look at this and I go, I mean, I don't know about you guys, but I look at like graphics all the time. So I look at this and go, oh man, you know what this reminds me of? Those diagrams where they show like the airports and all the flight paths from all the different airports. You know what I mean? Except those are arcs because they're actually, you know, flight paths on a sphere or like on a part of the sphere then flattened onto a drawing. So what if we were able to make like arcs that connected each of these up? Right? I mean, come on. That can't be uninteresting. All right, anyway. So now I'll open up this arcs plus 118, which I think is doing just that. And we have a red widget, which is kind of funny. Oh boy. Can't wait to see what that's all about. But again, we're going to make a bunch of points. We're going to cross-reference them to each other and then draw lines. But now where'd it go? There we are. I've turned the preview off for the lines because I'm not so interested in the lines. I want to draw arcs. And so what I've done is I've taken each of these lines, and let me just draw this step by step by sort of popping these things on, turning the previews on and off. Just sort of build this step by step. Okay, so here are my points. And I'm going to go ahead and connect each of these points up with every other point, right, with lines. Then what I'm going to do is I'm going to find the midpoint for each of these lines, okay, and populate it with a perpendicular frame. So I'll turn it to perspective view so you can see just a little bit better, right? You have a little bit of a plane on each of these. It gets a little chaotic looking, doesn't it? But that's what you're seeing are planes in top view, sort of looking down on the flat, you know, on an axis with the plane. But what that does is that actually helps us to find a normal direction, right? A perpendicular to each of those lines at the midpoints. And so then what do? I draw an XY plane. And then I find the intersection between the XY plane and all of these planes, which gives me basically just a bunch of trajectories. Turn those on. See if we can find them somewhere here. Okay, and then what do? Let me just go ahead and turn these planes off for just a second so you can see a little better. I draw the perpendicular bisectors using the midpoint that I found and then using the direction that I found. So I make a set of lines by start points, direction, and then some lengths. I'm going to preview that. So you can see how I'm drawing the bisectors there. I can change their length here. And I'm going to take the endpoints, and I'm going to use the endpoints, and I'm going to start connecting the dots. I'm going to take the start point of this line and the end point of this new line, and then the end point of the old line, and make an arc with it. So I'll just go ahead and preview those, right? Connecting the dots, so to say, with an interpolated curve. Right? So this is not unlike some of the stuff you'd be doing back at your drafting table, right? Honestly, right? So whereas if I measured each of these lines, found its midpoint, then got my triangle, made it something perpendicular to it, and then got a French curve out and said connect, connect, connect to make these arcs. Of course, I can begin to change the density again and change the sort of random distribution of it, the seed for the random number engine. And then of course there's other things like are we really finding the midpoints, or are we going to go somewhere else, you know, closer maybe to one of the ends? Or, you know, how deep or how shallow do I want these arcs to be? If I go all the way to 0, I'm back to straight lines again, right? Okay, and so again, just sort of thinking, you know, I would argue that part of what we do is just sort of trying to think about geometrically, how do we get from step A to step B, or, you know, point A to point B, and where we want to be in our process. And so this is the first step, being able to sort of read this stuff, right? This is a Grasshopper definition, so you read things from left to right, information flows from left to right. And so when we say, okay, let's say we want to use this populated two-dimensional region with points, right? It needs some parameters and needs some ingredients. Okay, and so the first parameter is the number of points to add. That's a number. We can even make a number slider and sort of consider it a variable that we can continue to adjust, right? And same with the seed. Okay, and so on and so forth, right? But as I start to make changes from left, the changes begin to propagate throughout and flow from left to right and modify everything downstream. All right, does that make sense so far? Right, I don't expect you to know all the details of this, right? Or where I came up with this widget or whatever it is, right? But fundamentally, conceptually, I'm hoping that this makes some sense here. All right, well, that's good news. I will open up arcs and, oh, actually, here, let me open up the original one here. 138. This was like arcs and circles, I think, right? From midpoints. So what you'll see is that, let's just take a look. I've made 4 points, right, by plugging in x, y, and numbers for x, y, and z coordinates. So this is a point, and this is a point, and a point, and a point. These are 18 by 18. Okay. Then I take these 4 points, and again, let me just turn these off, and then I can sort of, I can turn them on one by one here. Preview selected off. There we are. Okay, so we'll just build this from start here. Go ahead and turn these on. Preview selected on. There we go. 4 points. Yes, okay, so I'm plugging in some numbers, 0s and 18s for x and y coordinates here. And then once I have these 4 vertices, right, these 4 points, I connect them up with a polyline that I also tell it to be closed. So for a closed polyline, I say true, right?
Josh, sorry, I have a quick question.
Sure.
Do you add the points in the plane and then you assign your widget to each point?
Nope, nope, I'm just making, this is a widget where I just plug in x, y, and z numbers. So first thing I do is generate the number 0 and the number 18, then I plug in x and y and create points that way. So I'm not actually doing anything in Rhino. Does it make sense?
Yeah, thank you.
So this widget makes a point from an x and y and a z coordinate. Okay, then I use a polyline widget, right? This just needs the vertices to connect, and then I tell it, whether or not it's closed. So I'll go ahead and turn that on. There you see it. Now it's highlighted in green, hopefully. Let me go ahead and turn this to top view and make it a little larger. I'm also, really quickly, just to help you see it better, I'm going to turn the grid off from my Rhino interface here. So it's a little easier to see what I'm doing. There we are. Yeah, there we are. Perfect.
Josh, I have a question really quick. Is there a reason why the widget, the one that's selected right now, is like dragged way below all the other ones, or is that just it doesn't matter?
No, it doesn't matter, right? It's just more of how easily you want to be able to read these things.
Okay.
Start to look like a tangled bowl of spaghetti after a while.
Yeah. Okay.
I mean, even if I did this, it would, it would just look more chaotic, but it would still work the same way. It's a good question. Thanks, Julian. Polyline, what am I doing here? I have to remind myself. Explode a curve into its, like a poly curve into your polyline into its line segment. So I go ahead and just explode that. Right, so now I've made it, instead of a closed polyline, I've exploded it into 4 sides, right? I take each of those sides, I plug them in all at once, and I find their midpoint, right? So let me go ahead and turn the preview for that on, right? And again, I'm just saying to go like, I can go to 0 and I can go to the start point. I can go to 0.5 and go to the midpoint. I can go to 1 and go to the end point, right? I can go anywhere, place a point anywhere along any of these lines by simply moving that slider. It's like a street address. All right, so there's that. All right. Now I have a set of points. Now I have a list of points because what I did is I plugged in each of these sides into this widget all at once. And so, I plugged in 4 curves and I found the midpoints for each of those. So I get 4 midpoints out, right? I'm gonna just pull them out so that I have them separately. So I've taken the first item from this list of 4 points, and the second item, the third item, the fourth item. So there's this, here, let me just turn the preview off here. So there's this one, right? And that's on a separate widget, and this one, and then this one, and then this one. I'm just turning the previews on. All right, I'm going to use each of those as center points to draw circles. Not only that, but I'm not going to draw more than one circle. So you see, to draw a circle, I need a point, like a center point, and actually it's a plane, right? And so the origin of the plane is the center point, but then the plane also talks about the orientation that the circle is drawn in, right? So in this case, we leave it as default XY, but we plug in this point, okay? And then if we plug in more than one radius, we get more than one circle out, right? So this widget is all about just making a sequence of numbers that are equally spaced. And then we plug them in to make a bunch of equally spaced concentric circles, right? So again, there's also, besides being able to sort of change things with sliders, right? To change a parameter here or there, or to change a variable. Another nice thing about this is it takes care of the looping for us. So by using things like lists and trees, we can plug in multiple items and have it do all of these functions all at once to all of them, right? And so there's an economy of scale here, right, that begins to kick in. It's not so nice if, this is not such a great thing if you just want to make one circle. But if your task is to make 500,000 circles, Grasshopper is your tool, right? It'd be a hell of a lot easier than manually drafting each one of those bad boys by hand or in Rhino or wherever else. Okay, so, and we do that the same thing here and here and here, right? Yay. Now what do I do? This is just a little widget that tests for closed shapes. And so it says, okay, let's trim everything within this original polyline that we made, the sort of rectangle that we made, right, that's plugged in here. And so last but not least, we get just the portions of the circle that are trimmed out that we want inside. So this even trims it down to our 18 by 18 drawing for us. And again, if I start to modify where these things are being drawn, I start to get different effects, right? Now suddenly it's the same one. It's the other one. There's a 130, which is just circles and arcs from the corners instead of from the midpoints, right? Or anywhere in between. What's 46? I forget. Oh, this is a fun one. All right. 46, this looks like non-straight lines, right? Like there was so many non-straight lines evenly distributed across the wall. This one's a little harder because you have to try to figure out how to make non-straight lines. So what I do is I try to actually make lines, and then I try to add up just a little bit of jitter in one direction versus the other, and then reconnect with the curve in order to make a non-straight line. Okay, but again, there's a set of parameters here for the sort of number and the density, as well as the seed for generating some random variation throughout, right? As soon as you hit a certain, for instance, if I make these two seeds line up, 7 and 7 here, then suddenly we get something in that we don't want. We don't get random, we get ordered, right? All right. So essentially, this is about breaking apart, creating a list of random numbers, and then applying those random numbers to create another set of points that are connected up with curves. And then we trim things out again. Right. So you start to see this over and over again, this sort of pattern of generating some numbers, right? And you'll be doing that over the long weekend here coming up. But not to skip too far ahead, but the first thing we'll do is actually start making numbers, which is incredibly helpful. You'll start to understand, I think, after a while. Let me go to another one. This is number 1. I'm not sure what this is. It's making a Delaunay solution. I'm not sure why it's, I'll just turn this one off. Looks like junk. Let's see, we did 138. Or no, we didn't tie this one. So this one's slightly different, the 138 that we did before. Look at this. Right? And so it's just a variation on the one we just did, right? Circles and arcs from midpoints, right? But now we have something where we can actually make multiple polygons and find points along them to then begin to populate with circles and arcs. that polygon, you know, again, I mean, you know, you could say, let's say the wall is a four-sided wall, but if we start to think about polygons as, you know, the number of sides being a variable, right? We could actually begin to change the number of sides, right? And that begins to change the effect, right, in the drawing, or the size, right? And also the number of, what? All right. And so again, there's a number of different ways to sort of play around with this. Sort of virtual kaleidoscope wheel, if you will. Density, the amount of times it does something. And then trimming it out within an 18 by 18. Okay. So these are examples of taking, you know, the sort of procedural instructions that you guys did and drawing them out and starting with them as sort of something simple. And then in a couple of cases, I've provided some where they start to build on that, build up some complexity on top, right? By sort of playing a little bit with just the steps or just a rule or just adding an additional ingredient or a different ingredient, right? We can begin to actually have some pretty consequential effects at the end, right? Like we can dramatically change the results. 797, I think this is what? This is the, yeah, the offset, right? Let's see what this does. This one's apparently pretty easy to break. So I think part of what this does is it begins to find some random, numbers. And so it generates a curve based off of some randomly generated XY within a certain tolerance, right, in Y. And then connects them with a curve that then is offset over and over and over again. Okay, interesting. 118. We already did that one. You know, if I was smart, I would do this in order. What about 86? Did we do 86? Those are straight lines randomly distributed or evenly distributed along the wall. That's right. And of course, the amount that we're generating would be here, right? So we can get more or less dense by simply changing the amount of stuff that we're generating. All right. Okay, so I'm gonna go ahead and turn these off really quickly. You have these at your disposal that are already pre-built, and I encourage you to open them and look at them and play with them, right? The name of this next assignment between now and Wednesday is just sort of structured play. It's essentially that. I want you to fiddle around with these, make some copies, you know, change some things around, break them if you have to. In fact, if you came in with a bunch of questions like, why didn't this work? Or why did this widget turn orange or something like that? That'd be a great discussion to have on Wednesday. But I do want to show you how I generated one or two of these, and we'll just do it step by step, okay? And so that way you sort of see the process firsthand before we really start to launch in on these next week. You start making stuff firsthand, okay? But I want to show you that, but I also want to show you how to take results that you like and bake it back into Rhino and then make a PDF out of it. Because I'm going to ask for at least one PDF by Wednesday from you. Just sort of taking a result from one of these drawings, baking it into Rhino. Don't worry, you'll know what that means at the end. And then submitting it as a PDF. All right. So I actually like the circles and arcs from points. So let's try that one. Okay. What I'm going to do is I'm going to make a point. Okay. So I'm going to find in this case, a particular tool to make a point from an X, Y, and a Z coordinate. Okay. So one of the things you'll notice here in the Grasshopper interface is that there are a set of tabs, right? And so it's tried to sort of organize a bunch of these tools based off of what they do. So if we go to the Vectors tab, right, then we have things like planes, points, and vectors. I don't know why, but that's the way they are. And then when we want to do all things with curves, making curves, doing other things with curves, finding properties of curves, building geometries off of curves, here's the curve tab set. And surfaces and meshes, and then doing common transforms like move and copy and rotate and scale and all those other things, right? Twist and taper and flow and bend. There's some display tools, right? Going back the other direction, you know, past vector, we have things like sets. So what do we do with lists of things? How do we make lists of numbers? What do we do with data trees? Those sorts of things. This will actually come into play not too far from the future here, but suffice to say, you might be wondering, like, what the heck are data trees? And don't worry, we'll get to them. We'll cross that bridge later on. Math, right? So we can begin to define domains, minimums and maximums, a range. We can do things with matrices. We can do simple arithmetic like addition and multiplication. We can do all kinds of things here, actually. We also have Boolean statements like trues and false, ifs, thens, nors, ors. We can start to do more complicated functions, log functions, some of those constants like e's and pi and things like that. We can do trig functions, cosines, sines, and all those other things. And then of course we have some more stuff over here. All right, so, and then finally parameters. So here we have, you know, placeholder geometries. We have for geometry, we have numbers. We have, you know, different types of numbers, right? So we have the real numbers, or we could have integers, or we could have whole numbers, or we could have, you know, the variety of sets, right? So this is probably giving you guys all kinds of nightmares about math that you probably wanted to forget forever, but now you know that you'll be using it for the rest of your life in a practical way. So maybe it'll actually make more sense now. All right. So with that said, I'm going to go to vector. I'm going to find the tool that lets me make a point from an X, Y, and a Z coordinate, right? So by default, I think that's already set to 0. Yep. And 0 and 0, right? So I'm just holding my cursor over those inputs, right? What does this need? If we want to make a point from an X, Y, and a Z coordinate, it needs an X coordinate, it needs a Y coordinate, it needs a Z coordinate. Surprise, right? It needs 3 numbers. Okay. And so I can always right-click on each of these inputs and say set number and type 1 in. And I can always go back and right-click and change that. But if I know that it's going to be relatively variable, I can go ahead and just give it a number slider. Right? I can plug that number slider in. Now I can move that number, let's say in the X direction, right? But changing the X. Okay. I can double click on the number slider and I can begin to constrain it more, right? For instance, right now the minimum and maximum is set to 0 and 1. I could always change that maximum to something larger, like 10. I could always change the minimum to -10, let's say like that. Now I can move this, you know, further along, okay? All right. Double clicking on that again, I can constrain these to integers, so maybe just whole numbers, right? Or just the evens or the set of odds, right? I'll go ahead and cancel that. But what I'm going to do first is I'm going to think about just making a simple square, an 18-inch by 18-inch box. There's probably easier ways to do this, but one of the things I'm just going to do is I'm going to make a number just in the notepad. It's so anticlimactic. 0. Here we are. Come on. Oh, I don't know why I did that. That's so odd. What is it doing? Ugh. Sorry, this was too far zoomed in. I'm going to go ahead and copy that, make a paste, Control C, Control V. Double click inside, I'm going to call this 18. Why not? All right, so if I think about that origin, I'm going to make a point that's 0, 0, 0, and I'll make a point that's 0, 18, 0, and then I'll make a point that's 18, 18, 0, and then I'll make a point that's 18, 0, 0. Make sense? Let's try it. The first one's going to be 0, then 0, and 0. Okay, there's our first point. I'm going to make another point. Go back to vector, point from x, y, z. Right? This time I'm going to make 0 and x, 18 and y. Right? It's up here now. And then 0 and z. All right. And then the next one. This one's going to be 18, 18, and 0. Let's see, it should be somewhere over here. There it is. Ta-da. All right, and then last but not least, 18, 0, and 0. Now, it's already appearing as soon as I pop in the 18, right? That 0 and 0 is by default already plugged in for all the others, but I'm just going to go ahead and plug them in now. So now you can see we have this one, this one, this one, and this one. So by default, Grasshopper geometry, when you're previewing it in Rhino, is red. As soon as I click on the widget, it turns green. The geometry highlights in green in Rhino to let you know what you're looking at. Okay, I can go ahead and select these, maybe line them up, center them, evenly distribute them, centered. There we are. Something to help you out with keeping things nice and organized here. Okay, now I'm going to connect the dots. I'm going to make a polyline. So that's a curve. I'm going to go to primitives. No, sorry, splines. There we go. Sometimes I have a hard time remembering where things are. Polyline. Create a polyline connecting a number of points. All right. Now, I just mentioned sometimes I have a hard time remembering which one things are, and sometimes I just go in here and start digging around. But let's say I know specifically I just want polyline. I can just double click anywhere on the Grasshopper screen, and it'll enter a search command, or it'll bring up a search field. I can start typing in polyline. I'm at poly, now it's like, do you want polyline or polycurve or polyarc or polygon or whatever? So I'll start typing in polyline. There it is, right? Okay, so if you remember what you need, but you can't remember exactly where it's at, search, right? Just double click on this on the Grasshopper canvas, and I'll take you there. So what does it want? Not a big surprise. It wants the vertices to connect up into some sort of polyline. Okay, so I'll plug this one in. I'm going to plug these in order. So I'm going to hold down the Shift key. I'm going to plug another one in. And another one in. My Shift key and my keyboard's still on. Another one. Right? So it's connecting this one to this one, and then this point to this point, and then this point to this point. Now I could always plug this one back in again to finish it off. Although that didn't work for some reason. Or I could just say down here, close polyline. Right now it's set to true, and I could say false. Sorry, not right now it's set to false. I could change it to true, so it closes. Hit that opposite. I don't know why. It's Monday. Give me a break. All right. Anyway. Now, I'm going to just right-click and say disconnect and disconnect them all. Do this again. What happens if I do this out of order? I'm going to hold down the Shift key, and I'm going to plug this one in to this one. And it does exactly what you tell it to. It's going to connect this point to this point, and then I go back here to this one, right? And it's like, what in the what? Right? Now it's closed it, right? So it does remember the order. The order is really important here, right? It's going to connect these the vertices in the order in which you plug them in, okay? So that list that you're making of them, right? It's going to remember that. It's going to literally do exactly what you tell it to do, even if you're telling it what you don't want it to do. All right, so here, disconnect all. I'll go ahead and do this again. And sound effects, of course, are optional. I just do them because I'm weird. All right, here we go. Polyline. Why did I close polyline? That's great. We have the geometry we want, but we also want to actually just have each of these sides individually, right? So if we had a polyline, what we're going to do is we're going to explode it. All right, explode the polyline. I'm guessing that's somewhere over here in utilities. What is it? Let's see. Fit to curve, offset, explode, explode. There we go. Explode a curve into smaller segments. Yeah, that's really helpful when you have a polyline. You just want to explode it into smaller, all this the actual line segments. Okay. Just like you would in Rhino, right? There's an explode command here. Yeah, indeed. And same with the polyline command, right? And same with the point command, right? If I type in point here, it's going to say location of point object. I can click, or I can type in 2, 3, 0, and it places a point right there at that x coordinate. So again, this is just sort of, we're basically explicitly describing the process that we'd go through if we were doing this manually, right? Go ahead and plug these in. Let's see. So I plugged in one closed polyline, and I'm getting 4 line segments out, line-like curves out. That's perfect because I have 4 sides, and I'm going to explode this into its 4 individual sides. And bingo, it seems to have worked. All right. Now I want to find the midpoint of these. So I'm going to go to curves. I'm going to go to analysis. So I have a set of curves, actually, 4 of them. And I want to analyze them to find a point along each of them, okay? So what I'm going to do, we'll go over this actually in much more detail later on, so don't worry about it today. I'm going to evaluate the curve at a t parameter, okay? So what that means is I'm going to take these, okay, plug them in, and just think about it for a moment, right? Think about a line or a curve. Think about looking down on a Google map and seeing a road, right? Let's say we're looking at Tropicana Avenue. Everybody knows that one, right? Yeah, great. Runs east-west through most of town, right? Goes right past School of Architecture. All right, so if we think about Tropicana and we want to find a discrete point along Tropicana, right? What can we do? Let's say you're having a package delivered from Amazon on your address on Tropicana. What do you give it?
Cross streets?
You give it a number. One number, right? You say 4265 West Tropicana, right? Okay. So in other words, we can give this an address to find any point along this sort of linear curve, right? This line, okay? And what we can do is we can look at each of these lines and think about, assigning them an address where the start point is 0 and the end point is 1, okay? And then if we want to find the midpoint, that would be 0.5. Okay, and we can find any location along here then by changing that address, that street address. Okay, and so what I'm going to do is I'm going to plug in a street address or a t parameter, a t address, if you will. Okay, and now what I have to do is I have to right-click and say reparameterize in order to sort of normalize the address so that the address starts at 0 and ends at 1. And that way, now I can go to 0.5 and it's halfway along the curve, right? And I can sort of, again, what I did is I plugged in all 4 curves. I plugged in one t parameter, and now I'm placing a point at the location, at that address on each of these curves, right? So I get 4 curves, 1 t parameter, I get 4 points out. And I can modify the location. So if I want to change this to 0.5, see if I can manually get it snap it to 0.5. Now I can just double click and say 0.5, enter, right? There we go. But now I have a set of points at midpoints, right? And so let's make a circle, which is a curve, right? It's a polygon. Primitives, circle. Circle defined by base plane and radius. That sounds good. So these points will be my base planes. And then the radius, let's go ahead and make something that I can change, right? That's a variable. All right, now, if I want to make more than one circle, what do I have to do? Anyone?
Offset.
I can make a circle and offset it, right? Or I could just make more than one circle by plugging in more than one ingredient. So right now I'm making 4 circles by plugging in 4 points, right? 4 center points. So I have a circle at each of those center points, right? Now they have the same radius. Here we are. So if I plug in more points, I can get more circles. If I plug in more radii, I can get more circles, right? Let's plug in some more radii and see what happens, right? Because a radius is just a number, right? And so now what we need to do is we need to make a list of numbers, right? And what we want to do is we want to make the circles sort of grow in size. And so we need to make a list of numbers that grow in size incrementally. Does that jive? Line up? Okay, great. By the way, even if you shout out an answer and it's not exactly the answer I'm looking for, thank you, because it's really awkward to do this and only see like 3 mugshots and not hear anybody, and it's just me, and I can hear it, like it's so quiet. I can hear like my kids downstairs doing schoolwork. So it's really like unnerving. Anyway, all right, so let's make an ordered list of numbers, which you'll find that you do more and more of as we go through the class. They'll get so used to this. And here's one way to doing that. It's called series. Okay, it makes a series of numbers. How we do that is it needs a set of ingredients and a set of parameters. The first number in the series, then the step size for each successive number, and then number of times to step, right? So for instance, right now by default, it's set to start at 0, step by 1, 10 times. And so we get 0, 1, 2, 3, 4, all the way to 9. Yeah, that makes sense, right? And we can change that. So let me go ahead, and I'm just going to plug this into a notepad so we can see the outputs as we go. We change them, okay? I'm just going to go ahead and change this a little bit by changing some of the ingredients, right? So in this case, we can change the step size. Oh yeah, look at that. Not just step by 0.25 each time. So it starts at 0, step by 0.25, 10 times. So we go 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2, 2.25, as one does, right? Okay, so, and then we could always change the number that we have, right? I'm gonna maybe do more than 1. So maybe the number starts at 1 and ends at 30. And it doesn't make any sense to have like 3.5 times or anything. So we'll constrain this to integers, right, to whole numbers. All right, so now we can make as many as we want. Okay. Let's plug these in for radius and see what we get. All right. Something a little unexpected, right? So we're plugging in 4 points, a list of 4 points here and a list of 13 radius values. Okay. And so what it does is it tries to match them up 1 to 1. So the first radius value matches up with the first point, and the second radius value matches up with the second point, and the third radius value matches up with the third point. The fourth radius value matches up with the fourth point, and then it's run out of points, but it still has more radius values, and still it keeps going with the last known point and plugs in all the other radius values to it instead of keep going around. All right, so what I'm going to do is I'm going to go ahead and take this list, and I'm going to break it up into 4 discrete points again, and that way I can plug this in and make a circle at each one. Right. All right, so I'm going to take a list. I'm just going to pull out one item from it, right? Which item? By default, the first one. Annoyingly, computers start counting at 0 instead of 1. And so the first item will have an index of 0, and the second item will have an index of 1, and the second item will have an index of 3, and the third item will have an index of 2. It's always subtracting 1, which is so counterintuitive to us humans, but our biological carbon-based brains, not our silicone counterparts of the computer. All right, so I'm going to plug this in and get just one out. Okay, go ahead and copy, paste. All right, now I just need to change which one from the 4 I'm getting. So there's the first one, it has an index of 0. There's the second one, we need an index of 1. For the third one, we need an index of 2. We'll right-click and just change the third one, we need an index of 3, or fourth one, we need an index of 3. There we go. Okay, now I'll just plug this one in, and I get a set of those out. I can change this. I can change this. There we are. Maybe the count needs to be larger. I'll go with a max of 100. Why not? Let's go overkill. All right. Costs us no more time to do 100 than it does 30, right? So, and honestly, circles aren't that hard, so it doesn't cost us that much computational power either. Okay, we'll make one from there. We'll make another circle, but this time we'll use this one as the center point. Use all those radiuses. Just copy and pasting that circle widget so I don't have to keep finding it each time in the menu. There. So now we have this set of circles, this set of circles, this set of circles, this set of circles. Crazy, no? All right. You can make them more or less dense, more tightly spaced.
Hey Josh, what's the step that has like the start stop called?
The start stop. Where are you at?
On the top where you have the 2 sliders
the
connecting
step
to it.
here. So this one?
Yeah, what is that one called?
It's called series.
Okay, thank you.
No problem. Good question. So I go to sets and I can go to sequence and I can make a sequence of numbers. Series is one way to do that. We'll use range, we'll use series, we'll use random, we'll use, not sure what else we might use from that list. And then when I'm getting number sliders from the params tool, the params tab. So there's a number slider here. So my recommendation is to it's like learning how to swim. You got to jump in the pool, right? I mean, you can watch YouTube videos all day, but you don't know if you know how to do it until you actually get in, right? And so, to me, it's, you can back into it by looking at something and playing with it that's already built. You can try building part of it yourself. And then you can always refer back to the one that's built if you run into any problems, or say, how do you do this? Or why is this doing that, right? One way or the other, you can go backwards or forwards through this by once you just begin to generate by changing something with these, for instance, let me just back up. Let's say you had this 138 wall drawing that you did, right? Then what I want you to do is I want you to open up one of the 138 variations in Grasshopper, start playing around, whether you're changing the order of the steps, or you're connecting something to something else, or you're adding something, or you're changing some parameters. I want you to generate some difference here. Okay, does that make sense? All right, now let's just go through this one more time from a sort of pseudocode basis, where we just sort of say in plain English what's going on here, right? We're making points. In order to make the points, we needed X, Y, and Z coordinates, or just 3 numbers. So we made some numbers here, 0 and 18, and we're plugging them in for X and Y coordinates in order to create 4 points. We connect those 4 points up by connecting the dots with polyline. And then we explode the polyline so that we get each side as its own individual line. Then we find the midpoints of each of those lines. And then we start to use those midpoints as center points to draw a series of circles. Okay. We draw a series of circles by giving it a series of radii values, by simply making a series of numbers that incrementally step. Okay. So making an ordered list of numbers, plugging that ordered list of numbers in for radius, we get an ordered list of circles out, okay, for each of these. So at this point, this is what's spitting out 70 circles, and the other 70 circles, and then this set of 70 circles, and then this set of 70 circles. So I'm sure you guys have noticed this if you opened up Grasshopper. As soon as I close this, it's all gone. Oh no. Type Grasshopper in the command line, there it is, it's still there, right? But essentially all it's doing here, it's not really drawing much of anything in actual Rhino space. Okay, so there's nothing really to save. It's just previewing Grasshopper stuff in Rhino. So if we wanted to actually, let's say, we say this is perfect. We're looking at this and we're like, oh, it'll never get any better than this, right? Oh, wait, just kidding. There, now it's perfect. Oh, it's beautiful. It's incredible. All right. And we want to take a snapshot of this and bring it into Rhino and do something with it later, right? All right. Then what I can do is I can take each of these, because these are the things that are actually producing the circles, and I can right click on the label and I can say bake. Okay, and so it brings up a box here that says, okay, which layer in Rhino would you like to bake a static version of these circles into? So I could say default. I'll go ahead and just, okay. I'll do it with these circles. Bake. Okay. So I've baked 2 sets of the circles. Now when I turn this off, you can see them here, right? They're baked into, the static version of these are baked into Rhino. Okay.
Can you bake them all at once if you select multiple layers like that? Like if you do.
Maybe. Let's say I have this selected. I think you can say bake all that's selected up here in the solution pull down, right? So that can be helpful. And in fact, what I would do, if I was going to bake lots of generation, let's say, okay, here I have these. I would select all of these at once and probably group them, and that way I can just select the group. No, maybe not. Maybe I'll just select them like this. Forget the grouping. I'll select them, and then I would do that. Yeah, I would basically. So let's say I want to change this now to something with a different resolution. And I want to bake that out, maybe on a different layer, right? So I can compare the two in Rhino later on. I don't know why I turned my phone off. Doggone it. Then I would select all those again, just like you were asking Julian. Yeah, I can just say bake selected and bake all of those at the same time. Although it didn't ask me which layer, so it might just automatically bake them into the active layer, which baked them over the top of the other layers that I just did. So let me see if I can, here we go. Let me change this to the active layer and see if that works now. So I've changed it to layer 1. Let's see if I can bake selected. Turn this off. Yeah, right. So now I have this version or this version, right? Let's say you're doing this, and then maybe you're working on your own, and you're like you can't get the trim stuff to work, right? What I could also do is take this polyline and bake that in. I'll bake this on layer 2. Now I can use that as a trim tool, right? So I could say trim and Rhino after the fact. Let's say you get too far ahead of yourself, and then you're like, oh man, I need to trim this stuff out. And then I can just go back in and trim everything all at once, right? Like on the outside here. Trying to anyway.
Is there a way to trim in the Grasshopper plugin, or do you just have to do that when you're back in Rhino?
No, actually the ones that I pre-made already have a sort of trim function for a lot of them. But if you find yourself in this position, don't worry. You can just always, again, bake that 18 by 18 thing in and use that if you need to. Didn't trim that quite. There's still some things to do around the edges, but. So with that trim tool, let me think what that does. Let's see, and where did I find that? That might be in the intersect tool set here, where there's sort of region tests, like is it inside, is it outside, is it fully within, does it intersect? Let's see, curve. Just trying to find that tool here, collision. There's collision testing, trim with regions. Yeah, trim with a region. There we go, trim with a region, right? So in this case, what we would do is we would trim all of this stuff. I'm gonna have to hold down the shift key and plug multiple inputs into this one. I'll go ahead and turn this off for the time being. Turn all of these other things off. All right, and then I just need to give it this, let me just turn the preview off here. Just turning the preview off. It's still being generated. I just don't want to see them because it's annoying. I'll go ahead and turn the preview on here. I'll go ahead and plug this original polyline that we made as the region. Okay, if admitted. Okay, so here are all the curves that are inside after being split, and here's all the curves on the outside after being split. So if I turn the preview off, you won't see anything. Let me turn the circles off. I can turn the preview off so I can just sort of see what I want, right? So there's the inside ones and then the outside ones. So I'll go ahead and make a widget just to sort of contain all the ones on the inside or all the ones on the outside, right? So it sort of takes all these circles and then groups them into either what was inside or what was outside after they're split up. So there's actually an example of this in some of the ones that I provided today. If you're interested in trimming things out manually in Grasshopper and trying to get that to work on your own, okay? But it reuses this tool. And then all I want to do is bake one of these, not all of them all at once. So at this point, I would just bake this one. Not sure what the invalid object is, but there. So there's the trim version. Okie doke. Then from here, it's really simple to save as a PDF. Save as. PIDF. There we go. All right. All right, so let's take a look at this. Again, this is structured play. So this is a chance for you to maybe play around And I'm not being so reductive as to break things down step by step for you and telling you exactly what to do. Okay. But this is a chance for you to freely explore. Can you believe it? Your password is probably ... as well, right? I mean, what's the coincidence? What's the chances? 367, here we go. All right. Yeah, objectives. Yeah. All right, so here's the zip file right here. You just need to unzip that once you download it to your downloads folder or whatever. Once you have a PDF, you know, and again, this is just meant to be quick, but it is structured play, right? Submit PDF here, right? This is just an assignment I made quickly right before class. Just a chance for you to upload. Actually, I think in student view, this basically becomes a little form. You can upload a file and stuff. Yeah. I guess in instructor mode, it's speed grader. Okay. On Wednesday, we'll talk a little more, and we'll talk about how to make these things three-dimensional a little bit. Oh my goodness. And in the meantime, over the long Labor Day weekend, you'll be assigned a series of things to watch and do along with, right? So we'll actually start to build trusses. We'll actually build a bow truss. Then we'll build multiple bow trusses. Then we'll build the mother of all trusses, a three-dimensional sort of space frame truss, which doesn't really show through here, but you'll see when you actually do the videos. And so what we'll be doing is much more significant things with points, lines, and curves as we go, okay? By the time we get back from Labor Day, then we'll be ready to put all that stuff to use and start to actually generate some pretty dynamic lattices, okay? Which are both sort of volume fillers, spatial dividers, and structure all at the same time, right? So we can begin to talk about configuring patterns, the standard versus the non-standard. You'll be developing these things and you'll plug them into a poster, which will be pretty sweet, okay? That'll take us all the way to the end of September. Yay. All right, so that's where we're going in a nutshell. Between now and Wednesday when we meet again, what I ask you to do is play around in Grasshopper, break some things. Don't be afraid. Come prepared to ask, you know, why the heck does this thing not working? Or I tried this and then it turned orange. What does this error message mean? Or look, when it turned orange, it actually became much more interesting. You know, sometimes that happens, right? As I break something or do something unintended, sometimes those happy accidents are actually, well, happy. So again, structured play, and I want you to upload at least one example of something that you created then, from starting with these or trying to implement them on your own. Okay. Any quick questions about that? Again, don't belabor this. This is supposed to be fun, actually. You know, in your free time.
Are we able to make our own designs, or do you want us to still play off of the Soluit drawings and then just kind of vary from there? Or can we try making something like totally separate?
Vary from there. If you want to try to make something separate, then go for it.
Okay, cool.
Yeah. Then upload a second PDF. You know, of whatever it is. It could be totally uninteresting, but you could be like, dude, I tried. Look at this. I mean, you know, where'd I go wrong? Or, you know, I was trying to do this, you know. So again, this is structured play. So it's a good question, Julian. But, feel free to, you know, do more than just the minimum. That's how you learn. Okay. I'm gonna stop sharing my screen for the time being. All right, so let me think here. Yeah, so eventually we'll get to, you know, also rendering and generating drawing information, line work, and perspective, and for diagrams and ortho drawings and things like that of these things. So we're always trying to like sort of juggle multiple balls, you know, by the end of this thing, so that you're really trying to integrate all that you've done together. So that's always the idea. So we'll be generating some immersive perspectives and some diagrams showing the sort of part-to-whole relationships with these things. And they'll start to resemble more of the sort of typical architectural componentry that you're used to seeing, you know, structure-wise with like trusses and those sorts of things. So, all right. So on Wednesday, we're going to look at your structured play stuff, and we're going to try to start turning some of this stuff three-dimensional, which will be pretty interesting because we'll have that third dimension instead of having these flat things. And then over the long weekend, you'll have a more substantial assignment where you have to watch videos and then follow along and make your own truss stuff. Okay. All right. Any more questions? Just let me know. I wasn't paying attention to the chat. What was this? Okay. Hi, Josh. This is going to be recorded and posted. My internet keep lagging. Yeah. This is being recorded, so I'll upload this and post it and embed it into the Canvas module. Probably before Studio starts. Takes a while for Zoom to process it, but then after that, it should be easy to upload it to YouTube. Okay, so if you need to refer back to this, then feel free. Good question. Anything else? Type it or shout, whichever. All right. Then I guess it's just go fight win time. I'll see you on Wednesday. And thanks again for doing the first set of wall drawings. They look pretty. Some are really awesome, actually. I mean, like I'll go through and with the sort of best of show at some point with you guys. But yeah, take care, everyone. See you Wednesday.